Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, let's see what is new on the GitHub. Yeah, oof, we have a bunch of pull requests. I see. Let's see. Fix loop index comparison values, fixing that. Comment. Crash. Okay. I need a review on this one here, please. Let me bump Thompson's. Bump. Yeah. Okay. Okay, so what do we have? Fix warnings of register keywords. Fix warnings of register keyword being deprecated by introducing a macro for the register keyword. Okay, this sounds pretty safe to me. Register. Okay. Register, let me see. C++, register. C++, register keywords. The hell is that? Here. Keyword register. Deprecated until C++ 17. Okay. CPP macros, register. I wonder if that is even necessary, this register. Okay, so what I'm seeing here is position of include is not identical between generals and 0. Okay. Implicit long to H results. Fix implicit long to H result conversion warning. Yeah. That's so weird. Guess it's fine, yeah. What is H result? Is that a void pointer or is this a number? Integer. H results. Oh, it is a long. How? Implicit long to H results. Oh, why is this so slow? Man. Man. My gosh. It's so slow. I will restart it. It's unbearable. Let's try this again. Well, the whole system is just really slow right now. What the hell? What is so slow? CPU. OBS Studio. There's nothing suspicious here. Looks fine. So this guy is a number. It is a long, unsigned long. Long to H results. Unsigned long UL. Unsigned long. STD make signed. Make signed. Jesus Christ. Make signed. Is there like a function make signed? Yeah, what I don't like here is that some entries will have the static cars and others not. That's really, really odd. Yeah. Really odd. I wonder if there's a different fix here for this. We can do error lookup. Error. Can we do union, and then lift this in there, and then have a unsigned long error L? Would that work? Let me see. I have no idea. I just like trying see what this does. But I mean, this is also kind of weird, isn't it? Yeah. Okay, let's search for Win32DI keyboard. It's not found. think it would be better to simply cast all 2H results, not just those unsigned ones. Would be easier. Simply cast all values to H result, not just the unsigned ones. Okay, conversion from unsigned long. Okay. Let me also write here. Oh, you already says that here. Okay, so. Same here. Okay. Let me say casting just a handful of these make them a bit unholy to look at. How about simply cast all values to H results, not just the unsigned one. Makes the list a bit unholy to look at. How about simply cast all values to H result, not just the unsigned ones. Simply H results would do. Yeah, this is how I would have done it. Just cast all to H result, done. Then everything looks consistent, it's easy. Don't need to worry if one of these values ever changes to unsigned. Yeah. Yeah. Fix implicit long to H result. Fix conversion. Inside long. Fix implicit unsigned long to H result conversion warning. Compiler warning. Fix implicit unsigned long to H result conversion compiler warning. Implicit unsigned long to H result conversion. Labels. Compile. Bug. Minor. Build. Compile bug. Fix warning related to the use of printf and scanf. Printfp. Accept. Accept. Here, this. Good. So then we got that. Good. And oh. Huh. That's interesting. Get vector 2. If scanf fscanf what's up with this advertisement, man? Jesus Christ. Scanf returns an integer. Equals 1. Or not 0. Oof. Style. Several times in this file. I'm not sure about here. I mean, the technically correct way would be to compare it against 4, this line, right? If we want 4 arguments to be passed, so this should return 4. Yeah. It's in GUI edit. Yeah. Then let's compare it against 1. Yeah. Four. Bold. Where's bold? Here, it's uninitialized, so it does expect them. Yeah. Uninitialized, so it does expect them to be red here. Yeah. Several times in this file. LPCSTR. LPCTSTR. C string. Okay. C string. So that should be an operator, I guess. Operator. Yeah. Either conversion operator, wherever that is. Jesus Christ. Ugh. Huh. I don't know. I haven't seen it. LPCTSTR. Okay, that's not found here. LPCSTR, how about that? Operator. LPC str, LPC T str. There's no such operator. Construct from T. What? C simple string T. Let's look inside this guy. Let's search for operators here. Aha. PCX str. What is that? What is a PCX str? Jesus Christ. PCX. Okay, so it should be that LPC str, likely. Yeah. Okay, so pointer, this looks good. Why is this cast to void? Is this cast really necessary? I would assume that you can dial in any pointer, right? Stack PTR and send long, yeah. Spacing. It doesn't matter. Yeah. Fix compiler warnings related to the use of printf scanf. Labels, compile bug, minor. Cancel. Fix compile, how do we call it? Compiler warnings. Compiler or compile warnings? Compiler warning. Implicit unsigned long text conversion compile warning. Let's call this compile warning and not compiler. Compile warning. Compiler warning. Pfft. What is correct? Compile warning or compiler warning? Compiler warning. I don't know. What is better? Fix compile warnings. Register keyword being deprecated. Fix compile warnings for register keywords for use of deprecated register keywords. For the use of about fix compile warnings about the use of deprecated register keywords. Compile and bug minor. Compile warning. Compile warning. Fix compile warnings related to the use. Okay. Good. Then where do we continue? This change performs some extra sanitation on the player during reset to prevent invalid code paths being entered when the team list is cleared and teams are destroyed. The way to trigger the issue that this fixes is to play as a USA, build a strategy center, enable the search and destroy battle plan. Make sure you have a few units when exit again. The full explanation for what is occurring can be found in the attached issue. Let me see. Clear default team. What? Need to clear team handles to prevent invalid code paths being entered during reset. What? Bug fix. Clear default team. Delete the player. Delete player AI. Delete player AI. Clear default team. Can't we just set this inside delete player AI? What is this doing? Delete player AI. Okay. Clear default team. Okay. Okay, where's the set? Hello? Here. Okay, set default team. Clear default team. Okay, remove this comment. Remove this comment. Move this comment next to the other one. Move this comment directly below the other comments above. Need to clear the default team to prevent invalid code path being entered during resets. Yeah, there's no need to have like 1, 2, 3 comments. Just put this one comment below this one, done. Right. Then this one is a bogus comment because a function should not be described by where it is called, because this can change. And here, this is just a duplicate comment to this one. Avoid that. Just put this below this comment and we're done. Much better. Okay, other than this, I guess it's fine. I mean, it looks reasonable that we want to clean up some additional stuff. Let me see the report. Get controlling Search and destroy enabled while units are alive and you exit the game. This likely only affects the environment, has no effect on retail. Temporary team. Dependency between team objects being cleared during reset and dangling pointers being left on players. When a team is destroyed, the code attempts to move the player's objects to another team and moves them to a null team. And to determine if they are allies, the code then looks to get the objects. So, reset, team factory clear. Team factory clear. Okay. I see. Maybe it should describe it as clear the default team. Clear the default team to prevent using dangling pointers. I wonder. Creative function. Factory. Team prototype. Get controlling player. photo. Get relationship. Object look. Team prototype. Get relationship. Get default team. Neutral. I wonder if there's more that we need to clean up. Team. Yeah. Memory manager does not zero freed blocks of memory. No. This bug is occurring. Dependency between team objects. Dangling point does. Yeah. I see that it fixes it here, but I wonder if there's like a bigger issue at play here. I don't know. Look, object look. Dangling pointer. Becoming team member. Set team. I wonder. instance team. So let me open the constructor of the team. Set team null. Okay, it will remove. I see. No, that makes sense. Yeah. I wonder. Set team. No. Get default team. Set team. I wonder destruction of team. I wonder if a better fix for this would be to clear the default team in here. So here we have this stuff, ... and then here, ... and then here we could say, here we could say, if tm get default team equals it returns a pointer, right? Yeah. Equals this, then set team is called set team, right? Yeah. TM clear default team. Clear default team here. Perhaps this is more robust. Perhaps this is more robust for other cases where a team is deleted as well. Not just in player resets, player list resets, or team factory clear, or not just via just there. Clear the default team in this, yeah. Submit review. Yeah, basically what the advantage of this approach would be that no matter where the team is deleted from, it would clean up the default team in the team members list, right? Hold on. Get default team. This refers to the player and not to TM. Oh no, this makes no sense. Default team belongs to player. Yeah, no, this makes no sense, but maybe we can get the player here. Hold on. Get default team. But perhaps we can. Hold on, let me open this function once more. Here. Do we have the player here? The player list. Should be here. Player. Here. Pre-team destroy. This. Pre-team destroy. There we go. Aha. here, if default theme equals this, then default theme null. Why is this complaining? Ah, theme. There we go. Theme. Operand types are incompatible. I don't know why it's complaining here. It should be fine. Instead, try this. CPP. Clear default theme here. There we go. Or maybe move it behind the other one. Let me edit this once more. Maybe move it here behind it. It's probably a bit safer. I wonder, is this ever set to null here anywhere? Null. It's set to null and init and on destruction. Set default theme. Yeah, I think it makes sense to null it in there. Yeah. Yeah, and so it's called in theme destructor. Here, theme. 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 Yeah. Pre-team destroy. Yeah. Yeah. Okay. Good. I think that would be a better fix if it works. Yeah. Okay, what else do we have? Good. Then Thompson's is not reviewing this, or he's not happy with this. I don't know. He didn't say. Yeah. Good. On that note, I wonder if pre-team destroy AI. Good. How about we get back to the stuff that we worked on in the previous session. We wanted to run unassemblize against VS6 build. And there were problems. Big problems. Okay. Let's see. Okay. Right, we wanted to detect the end of a function, the proper end of a function, without the jump table and other garbage. The question is, how do we do that? Yeah. Shit. So we have function CPP here, and the problem is that this is not enough. This is not enough. Yeah. I don't know. Will this work? Valid instruction. What if we say let's do here size 10. Strat instruction index. Then we do pseudo symbols for jump or call. I mean, anything we do down here is just speculation. If it's jumping out, hold on. Yeah, so actually, what if we say here behind a return, if this is not this, then we break. Would that be fair? Maybe. Let me see. Could do that maybe. This one we can remove. Compare. Okay, so we have a hit here. Let's see. Call stack. Named function. Named function indices. Name functions. Begin address, end address. How about we don't break yet? We don't break. We don't break. Let me instead of break, let's just put a breakpoint here. Let's stop. Why is there a WW debug now? Huh? What? Where's this coming from now? Why was this include edit here? It is not added in generals MD. Where was this? Strange. Let's see. Custom just say makes the list a bit unholy to look. How about simply cast organization, not just the unsigned ones? Yeah, I think this is the easiest. Just H results. Done. This one could also have been casted, but okay. Yeah, I think this is much better because then, like, the alignment of all these guys is still the same, so it's easier to read these guys, right? Yeah, I think that's better. Looks good. Can be merged. Is this cast really necessary? It's what Copilot gave me back. Huh? Expects a void type. Casting the pointer to void ensures type safety and avoids warnings. Okay. 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 It always casts LPCT STR. Okay, well, let me dig it up again. C string. C string. C simple string. Here. LPCT str. LPCT str is not quite right. Looking at the following. And there was a cast operator here somewhere. Here. PCX str. Simple C string, base type, traits, base type. C string T. C string. CATL string. C string T. Where does it say the default type though? The base type. Base type is char here. W char. APC str. Okay, then go with APC str for consistency. But I think it is not quite right. Base type. What is base type? Simple string. here. Base C string. How do we know? I don't right now. I don't understand how the base type comes to be. Where is this specified? The base type. I don't understand that because there's no template arguments here. Where is it coming from? I don't know. C string. Base type. Can we go to chunk D? Let me search for this here. That's the wrong project. Here, file name. File name C string. Teacher. Aha. Does do teacher. Teacher. Okay, well, in that case, it takes a teacher. Yeah, then actually it's correct then. Yeah, you're right. LPCTSTR is correct because this okay. Okay, it's 2 1 4 4 4 4 4 2 1 10 1 2 Jesus 10 1 2 3 4 5 10 Yeah, looks good, I would say. Looks good. Technically, there is behavior change with scanf checking numbers of arguments passed, but that is probably desirable. So behavior change with scanf checking. Okay, let me get back to this guy here. Let's do a compare. Let's see where we hit here. Okay, so we hit the guy here. Yeah, let's see what the next is then. Let's see. Status. Yeah, mnemonic is move. 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 Mm-hmm. Okay, what else do we get? Tests. Jump. Six, 8, 6E3. It's still a far way from the end. I have the impression that this is not quite the right check here. No. No. How else can we check it? We can't check the last return because there is a return after the jump table. Fuck. I don't know. In 3, we can actually also not use because in debug builds there will be a debug breakpoint. Nope, we can do. Okay, let me put just a knob. Just the knob. Still get invalid ones. Huh? That sucks. I mean, so this will fix some cases. When there's a knob, when there's invalid one, then this will work correctly. But there will be some that will slip through. And I don't know how to catch these guys. Yeah. Let me, to avoid crashing, let me at least, let me this, let me, let's, for now, simply return here. How about that? So it doesn't crash at least. Okay. Let's see. View, match strictness, lenient. Okay, let's see. Okay, there we got one. Yeah. Here. Good. So let's go down. Hmm. Yeah, that's weird. That's really weird. Get poor. Okay, so here we have a return, and then we have this garbage here. That's so weird. Let's find more here. Oof. That is a lot, very different, isn't it? Jesus Christ. How does that happen? Huh. It's probably because the real function end is here. Reds. Here's a function end. And then afterwards, it's just random stuff. Yeah, we need to find a way to get rid of this random stuff, but I don't know how. How we do that? It's right behind the return. It's right behind the return. That's not many. It looks like most of these guys are fine now. I think we need to add we need to add a filter here. By the way, why does it not? Why does it not show a number on this guy? Why do we not see a comparison number on this all? All. All. Bundle name all. Let me search for M. Ah, it's the wrong M. Here. M label. Update info. Oh, I can't remember where this bundles interaction. Bundles interaction. Bundles UI info. Why is this not showing us a number? It's showing us a number here. But not here. Why not? Why not? All. Let me put a breakpoint in here. And then we do here, compare. Good. So what do we have? Similarity value changed. No. Okay, let me reload. Let's do it fresh. Okay. Okay, let me see how this looks. Percentages, 100. Okay. Token. Why is this 100 then here? Delete new percentages. think I would need to look at it in code if I see any more. Yeah. I wonder why he has bumped it from 60 to 100. Is that better? Percentages? 100? I mean, not that it matters much, but I wonder. Where's this used anyway? Percentages is here. Temp str. Where's this used? Huh? Here. Oof. E2R. Then this should be 33. Why is the number 100 chosen? Okay, let's see. Compare. Okay, so update info. Update info. Call stack. If label is empty or similarity value changed. Has a value, similarity value changed. Similarity. Yeah, okay, so where's this function being called? Update info. It's called here. Here. Okay, so let's put a, yeah, we already have a breakpoint, that's fine. Okay, let's remove this breakpoint here. Okay, let me actually put a breakpoint here. And here. Okay. Single bundle. List item, person descriptor. This is about named functions. This is not about the bundle. Hold on. There should be another one of these, no? Let me see. No? M. Okay, it's actually the only one. Item name, item. So this is, here, update bundle. Okay, so this must be called here. Okay, good. So this is called for the functions. Fine, this one works. Okay, let's remove this guy. Okay, here we have a bundle updates. Good. So bundle name is this guy. Okay, fair enough. Fair enough. Oh boy, this will be many, no? Bundle. Can we bundle type? Let's put a breakpoint here, please. Bundle type 1. And we have another bundle type. And there we should have 1. Yeah. Let's go. Bundle count. There we go. Okay. Reports. Oof. Oof. Why is this returning? Why is this returning? No similarities. Total similarity, 0. Okay, and then what? Oh, it's missing a comparison. Report is incomplete. Oh. Oh. Okay, so there is one guy in there that is not compared. Oof. Oof. If not, comparison records empty. Aha. Right, because there is a function that has no, that is empty. Oh, right. Okay, now I understand. It's compared. It's compared. I see. Maybe is compared shouldn't be then checked to the records, but is compared. So I would say we do record is compared. Is compared. Match function. Is compared. Comparison. Some comparison result. Ah, shit. How can we do this? could have like a boolean that says whether it has been compared. Comparison. How about we say bool compared false? Okay, where are these records being written to? They are written to here. Yeah. Then here we do compared equals true. Let's say can be empty after comparison. Can be empty. Okay. And then we do here is compared. Then we do compared. There we go. Comparison compared. Okay. I think that will work. Let's test this. Looks like Thompson's is happy now with this change. That's good. That's good. Approved. Okay. So after this, do you want me to move WW3D2 in parts? Okay. Then let's see. Oof. 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 Let's see. Okay. How about we... Okay, I see. So this doesn't work. Okay, let's change it. That's a shame. Good, then let me... let's remove this again. Well, it's... let's comment this out. Compared. Comment this out. Yeah. Oh boy, is compared. Okay, return comparison dot results dot records dot empty, not empty. Okay. Ah, jeez. Okay. Compare. Okay, then we need a different strategy here. We say program comparison descriptor update info. Breakpoint. Bundle UI infos. Okay, here build function similarity report. Here, if not is compared. And matched function. Matched function indices. If not is compared and m files 0 dot m named functions. Files get we need to say is missing comparison report is incomplete. We need to say if the functions have no instructions, then we don't care. Matched function. Okay, so matched function has named index pair 0, named index pair 0, index t. Okay. Let me take this guy here. M files, file. Get filtered named function. Revision descriptor. Revision descriptor, and then here we have named functions. Yeah. Okay, so I think what we need to do is here 0 m revision descriptor m named functions, and that is indexed by this. Yeah, no, m files. Let me stop debugging. Dot. Okay. So named function 0 equals that. Let's do a const. Then we do 1, 1, 1. And then we say if named function dot get instructions dot size equals 0, is not 0, or and hold on, and if it is if it bool has no instructions. No instructions. Or say if not this and not that. And let's say if has instructions. Not one, not that. Has instructions. Has if has the instructions is missing comparison. Yeah. Redundant codes. There we go. Name function, yeah. So if this one has, if that one has instructions, or this one has instructions, then it has instructions. How about we do, has instructions 0. Has instructions 1. Okay. Okay, I think this will work. Okay. After that, we can do the same with game engine. Okay, so compare. And we do have a breakpoint, right? Yeah. Okay, so 0, 1, 2. Okay, and then we go down here. Da da da. Okay, and this one, oof, still crashes. Oh. Okay. Get similarity as in. I think what we have to do is else continue. given function has no instructions, skip it. Say a function pair has no instructions, skip it. Okay, let's try this. Oh, slow progress here. Currently fixing up unassemblize to make it usable with EA code base. Perhaps it will be somewhat useful to check if behavior, if assembler changes unexpectedly when we do refactors. Since Delta builds have full PDB information, unassemblize can correctly compare these. But one remaining problem I see here is code behind the real function return. It is being interpreted. Ah, Jesus. Code behind the real function return is being interpreted as code behind the real function return, like jump table. It is being interpreted as instructions, and I have not yet figured how to correctly detect it. Strategies tried. Record last return. Cut off at NOP instruction. cut off function add knob instruction. Save the red instruction indices and cut off at last red instead of stuff behind that. Another idea is I can check if there is some additional information in PDB that can describe where the last real function instruction is. Possibly there is, because it needs to know where we can put breakpoints. Breakpoints, right? Yeah. Okay, let me test this guy now. So let's see. And we get a report and it has a similarity value. Fantastic. Okay, so this one is fixed. So now the single bundle will give us a match. Fantastic. 94%. Good. Let's change it to lenient. And now we are 96%. Good. So that is solved. Let me go to... let me get some water. Okay, so let me see. see. Function executable. Okay, how do we do it? Yeah, so I wonder, can we get more information? Begin address. This function. Set address range. Where's the set? Build functions. Build functions. Executable. Yeah. Okay, let me go to the PDB reader. Yeah. There should be the PDB function info here. Function info vector. Function info. There we go. So there we have a debug start address and debug end address. I wonder if this can help us. There's an address and debug start. Let's look at this guy. Let me see. Let me see. Let's see. Let me restart. Get virtual p symbol. Compile and function end. Let me see what that bullshit is. It's not calling this. Huh? Okay. Okay. Well, that's a shame. Why is it not calling this? Ah, shit. Okay, so there is no such thing. Oh, there is. Okay, hold on. It just took a while. Okay, that's good. Debug start. Okay, let me see. Oof, what is this? Function info. Okay, so function info. It has a length. It has an address here. Yeah. Debug start address. Length 13. Okay. And so then let's put a breakpoint here at the end. So debug start is there and end. That's start. Hold on. That's start and that's end. Let's put it here. Let's take this and there. Okay, there we go. Okay, so debug ends at 12. Aha, that's before the return, isn't it? Yeah. Debug end. Okay, that's interesting. That is interesting. So if we look at function info now, so we have the length is 13 hex. The debug end address is 12. So that's probably one before. So the return instruction is the last one, the last byte, and so it's one before the last. But that means okay. But we certainly want the return to be in there. Yeah. Debug start, debug end. Yeah. Okay, let's see some more samples. Yeah. Let's put it into our watch. Function info. So we have 2a end is 47. 2a is the length. 588. Yeah. Length. I wonder. So there's a place where we use length, right? Let me go there. This length. Where is this used? Oh boy. Function info address. Let me search for this guy. There must be a function somewhere where we transfer this to the executable, right? The question is, where is that? Where is that? Let me remove this here. Ah, boy. Address. Where's this? I remember there is somewhere a function where we transfer this to executable. But the question is, where is that? Is that maybe inside the executable? Add symbol. This one here, add symbols. There we go. There we go. Aha. To exe symbol, PDB symbol. There we go. Aha. There we go. Size is like, okay. So how about here? How about we do instead exe symbol dot address. Yeah, so this guy, and then let me comment these guys out. Dot size, we do PDB symbol dot PDB symbol info. Hold on. It's different. Okay, hold on. We need to hold on. Shit, where are we? To exe symbol. We need to make a specialization for PDB info. Yeah. So this one remains as is. And then we create a new one, to exe symbol. Here, PDB symbol. And there we do PDB symbol dot debug and address dot apps virtual minus debug start address. Yeah, and so this one, the size assert, so the size is smaller equal PDB symbol length, right? Yeah. Let me put a breakpoint in here. Let's see. Oof. Oof. Oh, that's not good. Exe symbol. Multiple defined symbols. Okay. Then how about we do symbol info here? We don't make it a template. Okay, like that. That should work, right? No, also fails. Error. Already defined. Huh? What? What? To exe symbol already defined. Oh, they need to be inline. I see. I see. I see. Okay, there we go. Okay, let's see. Load. Okay, we have a problem here. Is that because it's inline? It cannot put a breakpoint? Maybe. Yeah, that sucks. Well, in that case, we need to put it... Let's put it in a CPP here. There we go. Okay. Da-da, da-da. Put that here, breakpoint, boom. Ba-dum, ba-dum, bum, 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 bum. Bum, 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 bum. Okay. Let's try that. Put the breakpoint here. Okay. Loads. I do actually wonder if this guy... Yeah, let me run over here, yeah. Why is this not hitting any breakpoints here? What is this? Huh? What? Why is this not hitting breakpoints? Oh man. Okay, let's put a breakpoint in here then. How about that? Maybe it's not going through this code. But I would have thought so. Oh, hold on. There are multiple. Huh? Hold on. Oh, we only add PDB symbol info vector. We're not adding PDB function info vector? How? How? Oh. Okay. Why are we not adding PDB function? Overwrite. Overwrite exe symbols. Okay, how about we do PDB functions. PDB function info vector get functions. Then we say if not functions empty, then add symbols PDB function functions. Okay. Let's do a function info vector symbols functions. Let's do here add functions. PDB function info vector functions overwrite add functions. Maybe we can also do here m symbols shrink to fit. Maybe leave that for another time. Good, so add functions, add symbols, symbols. Function info. Okay. Overwrites. Okay, let's see that. So it would first add the symbols and then it would overwrite it with the function symbols. Yeah. Let's see. For what it's worth. Okay, there we go. Good. So add symbols. So it already added. Let me see. So symbols are already populated with quite a number here, right? 43,000. Good. So, and then now what we do is we have apps. So, okay. 114 minus 19. 19. Size 18. How about we do here +1. +1. Seems a bit like a hack, doesn't it? Return. How about we say this assert we should probably put somewhere else. Let me put this assert in the PDB reader. PDB reader here. Get functions. So we're probably looking at read compile and symbol. I assume we can just put it in here, probably. How about we put it here? Assert. Oh boy. Assert this minus this is smaller equal function info length. And then here we assert, hold on, yeah, end minus start, okay. And here we assert, sorry, offset, address offset, address offset. Oh boy. Right, I wanted to assert that this one, this address better match. My expectation is that it always matches this address, this, no? Hold on. Address dot apps virtual, this one. Yeah. Yeah. If that is not the case, then I would like to see what's up with that. It's possible that that's not the case. And then here, how about we say if size, if this size plus 1 equals pdb symbol dot address dot dot length, then we use length. How about that? Include the return statements, return instruction. Include the return instruction. And then here we do turn the last implicit red instruction. Else, let me put a breakpoint here. I want to see what happens. Okay, let's see. I think the asserts, yeah, will be interesting to see if any of these hit. Yeah. It is possible. If they don't hit, that would be great. They hit. Ah, shit. Okay. So, I see. So, debug starts. Start somewhere else. That's not good. That means we can't really use it. No. That's bad. That's bad, yeah. I thought there was hope here, but seems it's not. That's too bad. Yeah. Yeah, if these don't really start at the same address, then that's kind of useless, right? Yeah. Well, actually, what I can do is here. How about we just say, here we just make an assert apps virtual is larger or equal that. And here we say this is smaller equal that. Yeah. And then here we do debug end address minus address apps virtual. There we go, size. And if that size plus 1 equals then include the last implicit red instruction. Yeah. Yeah, I think this could work. That could work. Let's see. That could work. Let's see. Man, such hacks here. Okay, though, this should always be true here. No. Ah, hold on. Hold on, no, there's an error here. Debug end address must be smaller than address plus function info dot length. There we go. Length. Yeah. Let's try that again. Load. Yeah, we are slowly advancing. Very good. Very good. Aha. Okay, that was good. Good. So the address starts there. The size is debug end minus this. So size is 18, length is 19. So it will take this, include the last implicit red. There we go. Okay, so that works. Let's see some more examples. Okay, here we have a different situation. The address is that, apps virtual. Apps virtual. Size is 39, 42. I wonder if we swallow return instructions at the end by this. Could be, right? Yeah, then we swallow the return. Yeah. It's possible. Yeah. What is this symbol? Constructor. Size. Yeah, I'm a bit worried that we cut off stuff at the end that may not be supposed to be cut off, right? That's a risk now. That's a risk. It probably will happen often. Let's see. Let's see. This is looking good now. CPP macros, yeah. Okay. Looks good. Okay. Clear the default theme to prevent dangling pointer usage. It's a fix dangling pointer. Fix dangling pointer. At default team when team is destroyed. Okay, so where are we? Let's do a compare. I'm now a bit skeptical. I think we will now cut off all sorts of instructions at the end of functions, and we still get errors here. Source lines back. Okay. Shit. Okay, so we cannot really do this. Okay, how about we... How about in the exe symbol we introduce a new field? I don't know why this thing is 64-bit. Okay. It's really large. Let's call this size. Let's call this debug end. Or we say address, debug end address. Debug end address. Okay, so how about we put this here, exe symbol, debug end address equals that. Debug end address dot apps virtual. Okay. To exe symbol. Add symbol. Exe symbol. And then Then in the function CPP, how about we do, oh boy, we say if we say what we do is address 6040 last red instruction address equals 0. Okay, and then here we do let's remove this. Last instruction address. Actually, we can probably keep that. Last read instruction address, instruction count. And here we say instruction address here. Okay, and then we do we say if instruction address is smaller than end address. We need another one here. Debug end address. Where's the set end address? Set debug address range and address debug address. Okay. Function debug end address and address. Okay. Then let's see where this one is called. Here, build functions. Set address range, set debug address, symbol, debug end address. There we go. And then if instruction address is smaller, if that plus 1 is smaller, if that is smaller equal debug end instruction plus 1. Yeah, then we record this. Okay, I think we don't need this here. Let me remove that again. Okay, let me put a breakpoint in here. How do we know the size of this? Hold on. End address smaller equal end address smaller Yeah, I think this will work. I think this will, well, I don't know if it works, but just for this test, yeah, let me see. Let's see. I don't think we need to fix that yet. Good. Compare. Okay, so debug end address. Okay. Put a breakpoint in here. Debug end address. Okay. So exact matches here. Let me lift that into in here. Okay. Okay. Aha, this one is smaller. 7.9. 7F. Okay. Smaller than that instruction. D186. Yeah, okay. D186. Debug end address 28 smaller equal. I'm not so sure if this +1 is necessary now. Seeing these numbers here. Okay, how about we remove this one here? Let's try this again. Essentially, if we were to make two consecutive builds with the same code, it should always yield the same result, right? Yeah. Yeah. Actually, it's also a good test to see if there's any random code generation. Yeah. Oops. Okay, so single bundle, Lenient, 96. Okay, that doesn't look too promising. Okay, main menu updates. Let's see, what do we have here? Well, that didn't help. That didn't help. No, no. That's a shame. That is a shame. Yeah, I thought, I was hoping that this would stop here, but that doesn't. Okay, but maybe we can already merge some of the things that were definitely working. So this one we can reset. This one we can reset. This one is disassembled. This one will be reverted. Is disassembled. actually not sure if this check here is proper. That's just an assert. Just an assert. Can not empty. Where are we? Here. Fix asserts. Fix asserts when fix several asserts from several asserts from loading generals zh.pdb. Okay. Yeah, I'm not sure how to fix this thing here. This seems the debug address doesn't help much either, which is a shame. Yeah, do we have any other idea? Do we have this return here at the end and then random instruction starts? Quite frankly, I have no idea how to avoid this problem. I have no clue. Return. we would somehow need to know that it ends here, but how do we do that? I don't know. I don't know. Here's the code ends. Did we maybe make a mistake here? Not sure. Did we do a mistake here in the function here? I would have thought that this will work. Maybe it doesn't. Yeah. Well, apparently it doesn't. Clearly it doesn't. But why? Hold on. Here's the last return. Huh? Hold on. Did we do a mistake here? Last read instruction index. Instruction count. Index. Index plus 1. Index plus 1. So there is an index here. So we say index plus 1. Index plus 1. Oh boy. Instruction count is updated properly, yeah. Why is this? I don't understand why it goes over here. It should have stopped here because there is a return here. There's a return here and there's no other return here, right? Nothing else. So why is this growing up? Why is this growing up? There's no other return. If there was a return at last, then I would understand. But there's none. Yeah, last return instruction. Yeah, I don't understand. Let me, can we see the address of that thing here? Yeah, let me, this address, editor, notepad. The address is 1A84F0. Yeah. So we say here, if we put a breakpoint, if begin address equals that, then we put a breakpoint here, int a equals 0, and place a breakpoint here. Okay, let's see. I would like to see the flow of this garbage. Yeah. Let's see. Load. Very strange. Yeah. Okay, so we got a hit. Let's see what this guy does. Let's see. Okay, blah, 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 blah. Okay, blah, blah. Good. So eventually he will hit this guy, right? Let's put a breakpoint in here. Let's also put a breakpoint down here. Yeah. So. Ah, shit. There are multiple threads working right now. Nah. That's... Okay, that's not good. Shit. Okay, because there are multiple threads, we cannot do... can we turn this off? Just one thread at a time. Oof, then it will be even slower. Right. Let me see. Do we have a macro somewhere? Work queue. I think in their main function we have some command line argument for this bullshit. Here. Override thread counts for testing. Work to your thread pool count. 0? Yeah, let's set this to 0, 0, and then what happens? Then it should use single threads, right? Yeah, the problem is with multi-threading is so hard to debug, right? So this is always good to have a. It's always good to have a way to debug in single threads. Yeah. Good. Compare. Okay. I hope this is single threaded now. Let me see the threads. Threads. So we have a disassemble. There's just one disassemble happening. Okay. So I think this is single threaded now. That's nice. I would like to raise one thing. I don't need to raise it now. Runtime address. Okay. Let's see. Da 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 da. Okay, and we do. Okay, let's put a breakpoint here. So return address is smaller than this one. ed db. Yeah. Oh. What happened there? 97 ed 97. Oh, it is behind that. Ah. Aha, it doesn't have a return. Oh. Oof. Oof. Shit. Okay, let me start it again. That sucks. That sucks, yeah. So it never hits this return. But why? There was a return. Huh? There was a return in that function. Huh? I'm confused. Man, debugging this takes so long because the loading is so slow. Oh man. It's trying its best. Yeah. Huh. Why does it already show this here? Compare. Okay, there we go. So. Okay, let's put a breakpoint again here. So there is, we are still in this here, right? Yeah. Okay, and the first return reportedly is behind the debug end address. Huh. Not by much. By 8 bytes or so, 10, 12 bytes, 14 bytes, maybe. Yeah. Why? Why? Shit. Shit. Oh, this is so hard, this problem. Man. I don't know how to implement this. Yeah. Let me see this pointer. This. So the end is 804. This is quite a bit off. 804. Okay, so the first retain. Oh man. Okay. So it looks like debug end address doesn't really help. Yeah. Yeah, because it's yeah. Or maybe we can. Aha. No, that doesn't help. Well. Maybe what we can do is if the okay, so we know that there is garbage behind and there can be another return behind. That is. It would have been nice if the debug end address would have told us the exact place where the last proper return is. Shit. How can we do this? I don't know. I don't know. I don't know. I don't know. Shit. There must be some trick that we can deploy. A trick that works well. We know that there is a return. We know... Maybe we have to ask ChatGPT again for ideas. I mean, it must be possible to detect this. It must be possible, but I don't know how. And right now I'm just hacking it together, which is not very good. Yeah. Probably there's some elegant way. Yeah. Let me ask ChatGPT once more. How can we detect? How can we detect how can we detect the last instructions of a x86 function? Function that was compiled with VC6 of any. How can we detect the last instruction of any that was compiled using Zydis in C++? Let's see. For function epilogues. Okay. Return, move, strategy. Disassemble function instruction until you hit return or an unconditional jump. That is not part of a loop. Red F? What is red F? I mean, that's not very smart. Leave. Red. I don't know, this doesn't look like a good suggestion here. No. I don't know, I think I need to think about this a bit more. Yeah. 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 I think I will take a break here. It has been 4 hours, 17 minutes. That's quite a lot. Yeah. Good. I will take a break. I wish you a great day or night. Until next time. Goodbye.